Azure Service Bus. Enterprise messaging backbone in the cloud. Azure Service Bus is Microsoft Azure's fully managed, multi-protocol messaging broker built to support reliable communication between distributed applications. In modern cloud architecture, applications are rarely monolithic. They are broken into microservices, serverless functions, containers, or hybrid workloads running across regions and environments. When these components need to communicate, direct HTTP calls can fail if services are busy, offline, throttled, or restarted. Azure Service Bus solves this by providing a message broker layer that stores, routes, and delivers messages safely until the receiver is ready to process them. This approach is known as asynchronous messaging, and it decouples the sender and receiver so they can operate independently without needing to be online simultaneously. Service Bus is not just a queue. It is an enterprise-grade messaging platform offering advanced delivery guarantees, security, routing, scheduling, message ordering, dead lettering, duplicate detection, and transaction support. It is commonly compared to systems like RabbitMQ, Apache Kafka, or AWS SQS/SNS, but Service Bus stands apart with deep integration into Azure identity, governance, monitoring, and hybrid enterprise scenarios. Why messaging brokers are essential in distributed systems. In distributed systems, services interact to complete workflows such as processing payments, updating inventory, triggering notifications, synchronizing IoT telemetry, or coordinating business transactions. Without a broker, communication is synchronous, meaning the sender must wait for a response. This creates tight coupling, reduces performance, increases latency, and risks failure. If the receiver crashes or is overwhelmed, the sender fails too. Messaging brokers introduce loose coupling, enabling high reliability and scalability. Messages are persisted in a queue or topic, ensuring nothing is lost even if services are down. The receiver processes messages at its own pace. This pattern supports resilience, load balancing, retry logic, audit trails, and eventual consistency, all key concepts in microservices and event-driven design. Azure Service Bus extends these benefits by providing enterprise features that go beyond simple delivery, making it suitable for mission-critical business applications where message loss is unacceptable. Core concepts and architecture. Namespace. The messaging container. A namespace is the top-level logical container in Service Bus. It acts like a messaging domain, holding queues, topics, subscriptions, and security policies. Namespaces support regional deployment and scale limits. Applications connect to the namespace using a connection string or Azure AD identity. Queue. Point-to-point messaging. A queue delivers messages from one producer to one consumer. Producers push messages into the queue. Consumers pull or receive them. Queues ensure first-in, first-out delivery when sessions are enabled, support competing consumers, and store messages durably until processed. Topic and subscription. One-to-many pub/sub model topics support publish/subscribe messaging, where one sender publishes a message and multiple independent subscribers receive copies. Subscriptions are durable message views tied to the topic. Each subscription can apply filters, rules, and independent processing state, enabling complex routing. Message. The data unit messages are packets of data with a body and metadata, properties, message ID, time to live, scheduled time, session ID, correlation ID, etc. Metadata controls routing, tracking, scheduling, and validation. Advanced delivery features explained in paragraphs. Message persistence and reliability. Service Bus guarantees durable message storage. Once a message is accepted by the broker, it is replicated and stored according to the namespace's configuration. This ensures no data loss, even during failures or restarts. Message ordering and sessions. By default, distributed brokers don't guarantee strict ordering. Service Bus provides ordering through sessions, where messages tagged with the same session ID are processed sequentially by a single consumer. This is vital for workflows like bank transactions or ordered events. Duplicate detection in high-scale systems. Retries or network glitches can resend messages. Service Bus prevents duplicates using message IDs and detection windows. This ensures idempotent delivery without duplicate side effects. Scheduled and deferred messages. You can schedule a message for future delivery using the Scheduled and Queue Time (UTC) property. Deferred messages allow a consumer to postpone processing without deleting the message, retrieving it later via sequence number. Dead letter queue (DLQ). If a message fails repeatedly, expires, violates policy, or cannot be processed, it moves to a dead letter queue, a subqueue for analysis and replay. This supports error inspection and recovery pipelines. Time to live (TTL) and auto-expiration messages can have a TTL, after which they expire. You can configure queues/topics to auto-delete expired messages, preventing storage bloat and controlling costs. Transactions and Atomic Operations. Service Bus supports ACID transactions, allowing multiple message operations to commit or roll back together. This is crucial for financial or business-critical multi-step messaging workflows. Security, identity, and governance. Encryption and network security messages are encrypted in transit using TLS 1.2+. Namespaces can be locked to private endpoints, virtual networks, or IP firewalls, preventing public access. Authentication options. Apps authenticate using shared access policies, SAS tokens, or preferably Azure Active Directory, RBAC plus managed identity, eliminating key storage risks. Authorization and access control. Using RBAC, you can grant fine-grained roles like sender, receiver, or owner to users, apps, or automation pipelines. This integrates into enterprise governance models. Auditability and compliance. Service Bus works with Azure Policy, Key Vault rotation, activity logs, and diagnostic logs, supporting regulated industries. Monitoring and observability. Azure Service Bus integrates with Azure Monitor, application insights, log analytics, and metrics dashboards. You can track active messages, dead letter counts, scheduled messages, throughput, latency, failed deliveries, and consumer behavior. This makes troubleshooting predictable and data-driven. Real-world use cases, paragraph style, microservices. Communication in a microservices system. Instead of services calling each other, they exchange messages. For example, order service publishes to a topic, while payment, inventory, and notification services subscribe independently, scaling without dependency failures. Hybrid enterprise integration. Enterprises often connect on-prem systems to cloud services. Service Bus supports AMQP, HTTPS, and SDK clients, enabling secure hybrid message exchange. IoT and telemetry routing. IoT devices send telemetry to Event Hubs, but Service Bus is used to route command messages back to devices or back-end processors reliably, especially when devices reconnect intermittently. Background job and workflow. Queuing systems push long-running tasks into queues. Workers or Azure functions pull jobs and process them without blocking user requests, improving performance. Event-driven and serverless architectures. Serverless apps rely on event triggers. Service Bus can invoke Azure functions when new messages arrive, enabling scalable automation pipelines. Advantages in paragraphs. Azure Service Bus offers high reliability with guaranteed delivery, ensuring business workflows don't lose data. It enables massive scalability using topics, subscriptions, and competing consumers. Loose coupling makes systems resilient to failure. Enterprise features like scheduling, sessions, duplicate detection, transactions, and DLQs support mission-critical apps. Security is strong thanks to RBAC, managed identity, encryption, and private networking. It integrates seamlessly with Azure monitoring and governance. Since it is fully managed, developers don't maintain infrastructure, allowing focus on logic, not servers. Disadvantages in Paragraph Service Bus can be more expensive than basic queue services when used at very high throughput. It is not ideal for real-time streaming like Kafka. Some features like sessions require careful consumer design. There are regional limits per namespace, so global scaling needs planning. Vendor lock-in exists due to deep Azure integration. Debugging distributed messaging requires observability skills. Misconfigured TTL or retries may cause storage growth. It demands proper IAM, key rotation, lifecycle rules, and cost monitoring. Comparison summary in paragraph form: Service Bus is best for enterprise messaging and workflows needing delivery guarantees, while Event Hubs is best for streaming big telemetry, and Storage Queues is a cheaper basic queue without enterprise features.